You know, that is so true that kids are resilient. I really feel that my kids don't feel like temperature wise, especially like in the summer when they want to go swimming in Lake Michigan when it's still like 50 degrees and it's like, um, isn't your whole body numb by now? But apparently they don't feel temperature, so. All right, well, good morning, everybody. I think all the audio issues have finally caught up here. Um, Today, the plan is to look at 4.07. Before we get there, though, were there any major questions with 4.06 with our inverse trig functions? When I took a look at the homework assignments, the only thing that I caught maybe was making sure that your final answer was in the restricted domain piece of it. I think that's the only thing that I really noticed with that inverse assignment is making sure you're in the restricted domain. Otherwise, things looked pretty well overall. All right, the other announcement is just make sure that you're staying current with the lessons. We are working a little bit ahead of the calendar. In fact, we'll look at 4.07 today, which I believe is the last lesson in Unit 4. Then in Thursday's class, we'll take a look at 5.01. So we'll start the next unit. We will be bringing trig into the next unit as well, so it's not going to go away. So keep your unit circle. And then next week, I'm getting a little bit too far ahead of myself. Never mind. For some reason, I thought next week is the week before Christmas, but I lost a week in there. Eventually, we're going to get a little bit ahead of the calendar, and that week before Christmas break or before winter break, we will wrap up a little bit early. So that week right before break, we'll only have class on Tuesday, and Thursday will be a free day for you. So looking ahead there, just kind of note that we are working a little bit ahead of the pace of the calendar in the next upcoming weeks here leading into winter break. All right, are there any questions with anything? All right, then I think you're going to like today's assignment. Basically, it's kind of weird that I'm using like and story problems in the same sentence here. But we are going to be working with word problems and being able to solve those using our trig that we've learned so far. So a lot of things today are dealing with word problems, which actually they're not going to be that bad. I really enjoy this lesson. It's actually my favorite lesson out of the entire unit so far. So hopefully that'll translate over to you guys as well. The good news is that the majority of the problems we work with have pictures. But even if they don't, we're going to see enough of the pictures that hopefully you'll be able to create them on your own if presented with a story problem. All right, before we venture into our word problems, though, there are some vocabulary terms that you need to be aware of. You should have heard of these in the past. I think we maybe went over them in Algebra 2 a little bit. But angle of elevation and angle of depression are going to come up a lot in your word problems. And knowing what those represent is going to help you label that triangle appropriately to be able to solve the word problem at hand. So what you need to know is that the angle of elevation and angle of depression are created from your line of sight. So everybody has a line of sight when they're looking straight forward at something. So right now I'm looking right at you, right? I can see that webcam. My line of sight is looking straight forward. If I were, so I'll keep my arm kind of out here and I'll shift so you can see it, slant it a little bit more. If I were to avert my eyes up, I am creating an angle of elevation. So I'm looking upwards. The angle of elevation is right between my arms here, right? So that angle at which I'm looking upwards is what we call the angle of elevation. Now, from the line of sight, so looking straight forward again, if I were to avert my eyes downwards, more towards the floor, I'm creating an angle this way. The angle right in here, for which I'm looking down at, is what we call the angle of depression. So right here, notice how they do have kind of people standing with and a line drawn with the line of sight, or the straight forward right there. So if they were to look straight forward, that's that horizontal line there. And then depending on if they're looking up or down, that's creating your angle of elevation or angle of depression. Now I want to pinpoint something here. Notice that we have right here that horizontal line, and if I wanted to, out on Mount Rushmore up here at the top of this triangle, I could also create a horizontal line. What is true about the angle right here and the angle of elevation that they have labeled in the triangle? What is true about those two pieces? They are equal, right? So if you have a person up on top and maybe I should bring my little stick figure guy down a bit, where he's looking straight, and all of a sudden he looks down more, his angle of depression is going to equal these people's angle of elevation. Does anybody remember why those are equal? We're going back to our geometry class here, so we might be stretching it just a tad. What are these angles called? Anybody remember? Not coterminal. Nope. You have a set of parallel lines cut by a transversal. Ooh, inner, close. It's interior. So they're actually alternate interior angles. Yeah, so that inner was close. So alternate interior angles are congruent when you have your parallel lines. So that's why the angle of depression right here for this person is going to equal the angle of elevation down here for these people. That's going to be important to note as we move forward, because sometimes with our picture, we're going to have somebody standing up on top looking downwards, and we're going to need to identify this angle right here in the triangle that's below that. So knowing that these two pieces are going to be congruent or equal is going to come in handy. All right, are there any questions with the angle of elevation and the angle of depression terminology there? All right, then let's go ahead and we're just going to jump right into our examples today, because technically we already have everything we need to know to solve these word problems. We just really need to pay attention to our trig and know which trig function is going to help us create our equation to solve. All right, so they start us off nice. They give us a picture of what's being described here, but let's make sure that that picture matches up to the description or the story problem above. It says the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse 130 feet above the surface of the water is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. All right, there is a lot of information there. So first of all, we've got to draw the lighthouse, and we'll draw the buoy out on the water, and we'll create a triangle between those. Now it says the angle of depression of a buoy from the top of the lighthouse. So right here at the top of the lighthouse, looking out, you're going to have to look downwards to see that buoy. So the 6-degree angle of depression in the picture needs to be placed right here. We also know that the lighthouse is 130 feet tall, so we have that measured as well. We want to find the distance from the lighthouse out to the buoy, so they mark that as X. Now, those alternate interior angles that I just mentioned on the previous slide come into play here because we're going to need theta. We need an angle measurement besides that 90-degree angle in the triangle. So we need either this piece or this one. And I'm just going to use the theta that they have marked because technically it's a little bit less math that we have to do. You could go ahead and find this one using subtraction, but this one you don't have to do any work at all. What is the degree measurement for theta in our picture? Yeah, it's that 6 degrees. So generally, if we can use the information that they give us, that's the route we're going to want to take. Now, this does make a 90-degree angle fully here. So you could subtract and you could label this one your 84 degrees and then set up a problem that way and you'd still get the same answer. But we'll go ahead and use the 6 degrees that they gave us. All right, so which trig function are we going to want to use here to help us solve for x in this triangle? Tangent, yeah, opposite and adjacent. So the OA, right? That's your TOA. So you're thinking like your SOHCAHTOA piece from geometry days. Yeah, opposite over adjacent. So we're going to say tangent of 6 degrees. Because we are looking at that theta angle down here, equals 130 over x. Now this just becomes a very basic algebra problem. How do we solve for x in this equation? Multiply by x, yep. So start by getting rid of that fraction. And then divide by tangent of 6 degrees. Yep. So I'm going to expect that at some point as you're working through this lesson, you're just going to be able to take that 130 and divide by tangent 6, and you're going to be able to do those 2 steps in your head and just use your calculator to get the result. So that I'm kind of expecting that you're at that point that you should be able to isolate x just by punching the steps into your calculator and not having to write it out fully. All right. What do you get for your answer here? We need to be careful as we're punching this in the calculator. Yeah. See, I didn't even have to say it. So Rebecca's like degree mode. That's the one thing that we need to be careful of because with these word problems, they switch back and forth. I would say that maybe 90% of the time they're working with degrees, but it's not uncommon for them to throw a radian measurement in there once in a while. So if you ever see pi pop up in a story problem, you know you've got to switch back over to radian mode. If you see the degrees, you've got to make sure you're in degree mode. Yee! Okay. Everybody else get what Tommy had? I think I have that same result that she did. 1236.87. What's the units of measure here? Feet, right? Yeah. So again, with the story problem, we do want to put in those units of measure just so we know what that number is referring to. So the buoy is 1,236.87 feet from the lighthouse. Rounding to the nearest hundredth is totally fine if you want to round to the nearest thousandth. So you have 3 numbers at the decimal point, that's fine too. So hundredths or thousands, when you round, either one's fine. Okay, not that bad, right? See, this is why I really kind of enjoy the word problems at this level, because if you can get the equation set up, It's just your really simple algebra to help you solve it. The picture piece of it, drawing the picture, I think is going to be the hardest piece of it all. All right, they're not all going to be that simplistic though, so let's take a look at example 2. It says from the top of the 100-foot tall hall here, a man observes a car moving toward the building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? All right, this is a little bit more complicated process. Before we actually start with it, let's just talk strategy. What ideas do you guys have for us to find the distance that the car actually travels? Find each distance from the building and then subtract them. Do we like Tommy's idea? I see Isaiah, find the distance and subtract. That's the same thing Isaiah was thinking too there. All right, good. Notice there are 2 right triangles that are drawn here. I'll try to color code them appropriately based on the color of the car. The color of the car only changed too so that you know, I don't know why they used a blue and a red if it's the same car that's moving, but point 1 and point 2, I guess, to make their thing known. So we are looking at that right triangle in each picture. So let's go ahead and start with the blue. Notice that they have the angle of depression in there from on top of the building. They already put that in the appropriate spot in the right triangle for those alternate interior angles. So they did that step for you. Right? Maybe it's like one of those color changing cars and it went through a puddle and it went from blue to red or something. Who knows? All right, so I'm just going to draw the blue triangle separately here. All right, which trig function do we want to use to help us solve this one? Tangent again. Yeah, tangent is going to be a pretty common one, although sine and cosine are possibilities as well. But tangent seems to be kind of a popular setup that we are just set with, I guess. All right, again, multiply by x, divide by tangent of 22. What do we get for that first distance? All right, good. And I'm just going to alter my picture a little bit because technically that length isn't just the x, it's the x plus d in the diagram, right? It's that entire space there. So I'm just going to change that in our picture just a little bit. All right, good. Then we need to find the red. So I'm going to change my color here, although that's purple instead of red. Whoopsie daisy. We got a 46 this time around. So again, looks like we're going to have tangent here. So very similar setup, only the degrees changed with the problem. It does, right? What are we going to get for D? A 96.6. All right, now you guys did tell me that we were going to subtract these because we do want to find just the x piece, so we're going to subtract those d's off, right? So they cancel out. So let's subtract the 2 values to find our total. a 150.9-ish. All right, you will have a problem similar to this on your homework assignment, by the way. So close. I think in the homework assignment, you actually are going to have to set up the drawing yourself there. So remembering that you have this one to kind of come back to and look at as an example might help. All right, we're a week or two, we're 2 weeks. Gosh, my timing is just way off. Thanksgiving was technically a week and a half ago, I guess we can call, but it fits right in for that Macy's Day Parade balloon, right? So here we got this really big penguin balloon in a parade. It says that 2 cables are attached to the underside of the penguin, which I don't know if necessarily is enough cables for that giant of a penguin, but we'll see. It says 2 cables attached to the underside of the penguin make an angle of 48 degrees and 40 degrees with the ground and are in the same place as a perpendicular line from the penguin to the ground. If the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? All right, so they do have a picture for us, but it's not, some pieces are labeled, but not all of it. So let's put in the missing information. Let's start with the angle out here. We do know these 2 angles, but which one is which? So one of these angles has got to be 40, and one of these angles has to be 48. But which one goes where? How about this one, the outside one? Is that the angle of 40 degrees, or is that the angle of 48 degrees? That's your 40 degrees, right? If you're further away from the object, that means your angle is getting smaller, right? You don't have to look as high up to see it. So if you're standing in front of an object that's really tall, to see the top of it, you'd have to look pretty far up, right? So the closer you are to this tall object, the higher up you have to look. But as you keep backing away, the less you have to look up, right? So that angle is declining as you back away from that object. You don't have to look up as far. So it makes sense that the angle that's further away is 40 degrees, but the angle closer to it is 48. All right, what exactly are we solving for in this picture? The height of the penguin. Yeah, but there's another piece of information that's missing. What other thing do we maybe have to mark here? Because I'm not sure we can technically find what we're looking for without something else. What else are we going to be using in our picture to help us solve? The distance along the ground. Let's let that distance right here in pink be represented with an X. Hopefully we can figure something out along the way where we can subtract the X's or the X's cancel out somehow and we can solve just for H. But let's start with the larger triangle. What can I maybe set up in this larger triangle to help me solve for H? So which trig function are we going to use? Tangent again. So we're going to say tangent of 40 degrees equals opposite over adjacent, which is 10 plus x. All right, to solve for x, we're going to multiply by that 10 plus x on both sides. I'm going to put parentheses here. If we need to distribute, we'll come back to that step, but we'll just leave that there for right now. Is everybody good with how I got that 10 plus x for that bottom base there of the triangle? Okay, let's go ahead and look at the pink one then. So in the pink triangle, we can set up a very similar situation. We can say tangent of 48 degrees, though, equals h over x. And if I were to solve for h or solve for x there, and maybe it might be better if we actually solve for x in these. We'll come back to it and take a look. We may have to change my plan of attack here. H equals x times tangent of 48. For the 41, if we look back, I think it's okay because we're going to do opposite over adjacent. So h over 10 plus x. So I think that's going to be okay. It's okay. It's early in the morning, and I think right now, because I can see that we want to use substitution to try to help us solve for that x value in here. But I'm second guessing myself in that we actually want to solve for h. So maybe we should rewrite the equation so that the h's are inside here and the x's are what we had solved for out here. So I'm starting to second guess myself just a little bit with this, in that we actually want to solve for h, and I'm trying to look at the end product here and if it'll be faster if we just rearrange it now versus having to use a triangle again in the end. And you know what, I don't really think it's going to make too much of a difference, so we'll just keep going with this route and we'll actually solve for x, but then just remember we have to go back to solve for h later on. So I think it'll be okay if we go this route. All right, notice that we do have these h's that are the same, so let's let them equal each other. Well, I am writing this out. I'm probably going to need your wonderful algebra skills to help us lead us through how we can solve for x in this problem. So be thinking how you're going to solve for x in this. All right, so I got it written out there. The two parts are equal to each other. How are we going to solve for x? You can divide by tangent of 40. Are you thinking of 40 or 48? I don't think it's really going to matter because they're both just constants, right? So what I'm actually thinking to make this a little less confusing is let's just do tangent of 40 degrees and tangent of 48 degrees and get that decimal value. So real quick here, what are we going to get when we convert those to decimals? So what's tangent of 40? And then tangent of 48. Okay, 0.839. $1.11. Okay, so now that's a little bit easier when we don't see the word tangent in there and it's just a numerical value instead, right? Because I'm probably going to want to distribute this 0.839 through the parentheses. And then start moving stuff around so that we can solve for x. Let's go ahead and subtract the 0.839x from both sides. What do we get when we subtract that over here? A 0.271. Okay, I'm taking your guys' word on this. And then when we divide that on both sides, what's x going to equal? About a 30.9-ish. And it is okay for us to be a little bit off because we did round throughout that process. So this is a 30.959. And x was this bottom piece though. So if I want, I'm going to come back up here in this pink setup, and instead of putting the x, I'm going to put the 39 or 30.959 in. And then let's solve for h, because that was the end goal after all, right? Was solving for h. So using substitution there and a quick algebra method to solve, what are we going to get for the actual height of the balloon? You guys get the same thing there? So you got to multiply both sides by the 30.959 in this setup to solve for h. And you should get about 34.38 feet. Awesome. Questions with that? So that was a lengthy process. All right, let's see. I'm going to skip around in my PowerPoint. Here, let's do one that doesn't have a drawing, just so we get some practice with that as well. So it says, a guy wire attached to the top of a radio antenna is anchored at a point on the ground 10 meters from the antenna's base. If the wire makes a 55-degree angle with level ground, how high is the antenna? All right, so let's go ahead and I'm going to draw in a picture here. Obviously, we need a right triangle to be able to solve this. If it's not a right triangle, we can't use our trig functions. At least not yet. That's what Unit 5 comes into play. All right, so here's the right triangle. Let's just say that this is the antenna over here, right? You have this big antenna coming out of the ground. And then this would be the wire that's attached to the ground at the spot out here. All right, what markings can we put in the triangle? So what can we put in our triangle? What can we add to it? $10 meters distance from the antenna. So which part is 10? The actual antenna or the ground side? The ground side is your 10, yes. It's the distance from the antenna out to the wire. So that ground piece of the triangle is your 10. All right, we have a 55 degrees. Where do we put that? Between the wire and the ground. All right, 55 degrees. And what are we searching for? So we got to put a variable somewhere in. Are we searching for the antenna or the wire length? The antenna height. All right, so we'll put in our variable over there. Awesome. That wasn't too bad, setting up our own triangle and labeling things there. Now let's set up an equation so we can solve. How are we going to solve this one? Tangent again. Yep. Like I said, tangent is, for some reason, just the one that's used the most often. However, sine and cosine can work as well. So if the picture is just drawn perfectly, sine and cosine could be viable options. All right, what do we do to solve for x? Yeah, multiply by 10 on both sides. And you definitely need a calculator for this. A 14.28 meters this time. Yep, meters. Good. Beautiful. All right, any questions with that one? Otherwise, I think I have one other one that we can draw the triangle in for. Yeah, here's another one. Okay, the angle of depression is 19 degrees from a point 7,256 feet above sea level on the north rim of the Grand Canyon level to a point 6,159 feet above sea level on the south rim. How wide is the canyon at that point? All right, any ideas on how we can set up a triangle here? Or a picture in general? I like Isaiah's thought. Start with the right triangle. Maybe we can go ahead and figure some stuff out from there. Tommy thinks we got to subtract to find the height of the triangle. So if you're starting up here at 7,256 feet, so a person up here is starting at that elevation. They're looking down here at something that's 6,159 feet. We can subtract those to find the actual height between them. What do we get when we subtract those? 1,097. All right, so I do like that idea. What else can we add in? 19 degrees at the top corner. So hold on. The angle of depression is 19 degrees. Is the angle of depression, and let me draw in his horizontal line of sight there, is the angle of depression this piece right inside the triangle, or is the angle of depression the piece that's on the outside of our drawing? It's on the outside part of it. Yeah, this is that angle of depression. So you have that person standing at the top there looking straight out, and when they got to look down, they're looking down at that 19 degrees. So it's technically on the outside. So if it's on the outside, that correlates to the inside angle, but on the ground piece of it, the lower piece, right? So down here is 19 degrees. There you go. So that's a piece that is a very common mistake with labeling where the angle of depression is. The angle of depression, usually when they talk about that, is on the outside of a right triangle somewhere. So just kind of keep that in mind, that usually that angle of depression is an outside measurement of some sorts. And you got to correlate that to what would be inside there. All right, what are we searching for? We have to have a variable that we're going to solve for. Where does the variable go? The bottom length, Tommy says. The width at the bottom. Good. So how far apart are the two canyons there? Good. All right, so we got the picture, which was the hardest part. Let's set up an equation to help us solve for that x. All right, which trig function do I want to use? Tangent again. If I'm using the 19 degrees there, what's the ratio we're going to set that equal to? (1097) over x. Work your algebra magic to solve for x there. So multiply by x, divide by tangent of 19. And what do we get for the distance? Anybody second Tommy's result there? Isaias did. Okay, great. And that's what I get as well. Fantastic. All right, I told you that these weren't going to be that bad. I think the picture piece of it all is going to be the complicated portion of it. Once you can get the picture with everything labeled, then look for which trig function you want to use to set up your equation and then work backwards to solve. So once you have the equation, solving is actually the easy part of the process because it's just some quick, simple algebra steps and you're there. But the picture part of it is what we want to really pay attention to and make sure we set up correctly. Okay, questions with what we did here today with these word problems? All right, then I think you're going to be good to go with the 4.07 lesson. All right, it is the last lesson, though, of the unit, so that means you have a test this week. You can use your unit circle, and obviously you're going to need a calculator for that test. Have a Google Doc open and ready to go in case there's any type of graphing things. The other thing I noticed with the inverse function one, assignment might have been the 4.06 one. The very first question, it asked you to graph. And I think a lot of people were stumped on how they could graph something. Don't let the real basic stuff stump you. Graphing means put it into a calculator and see what the graph looks like. All right, so don't let that real simple stuff kind of stump you. Don't overthink things when you get to the test. Okay? All right, that's all I got for you today. So when I see you guys on Thursday, we'll actually start Unit 5, which is actually just going to kind of pick up right where we left off. We're going to need our unit circle again, and we're going to keep working with our trig functions. So we're just going to follow along in Unit 5 with what we did here in Unit 4. All right, have a great day, everyone, and I'll see you all again Thursday morning. Bye.
Recording stopped.